Hi everyone, in today's presentation we are going to cover Chapter 3.1, Introduction to Integers from the OpenStax Pre-Algebra textbook. Now the learning objectives for this presentation include to locate positive and negative numbers on the number line, 2. Order positive and negative numbers, 3. Find opposites, so these are number opposites, 4. Simplify expressions with absolute value, and 5. Translate word phrases to expressions with integers. So let's start with this first introduction question here, and I'd go ahead and pause the video at this point in time and think about what is the meaning of a negative number and an integer, and what might be the difference between the two core vocabulary words. Okay, so the meaning of a negative number is it is a number that is less than 0 represented with a minus sign. So if you look at the number line here, we're looking at the middle point. 0 is basically separating out the positive side of the number line, 1, 2, 3, and the negative side of the number line, -1, -2, -3. One thing to note here is positives and negatives are direct reflections of each other. Then looking at the definition of an integer is any whole number, either positive, negative, or 0, without any fractional or decimal parts. So we're specifically looking again at +1, +2, +3, +4, all those whole numbers on the positive side of the number line, and -1, -2, -3, all the negative whole numbers on the number line. Now, you might ask, well, isn't there such thing as a negative fraction or a negative decimal? And you would be correct, right? If you went to the store and you spent $5 and let's say 50 cents on your credit card or whatnot, that would be a negative type of value. However, it's not specifically an integer. An integer is something different. It has a different definition to it, okay? So in this topic, we will be looking then at either positive or negative whole numbers, essentially. So the first type of concept we will be taking a look at is how to identify spots or dots on the number line, values on the number line, if you will. So we'll start with this initial question: where is the dot on the number line here? Now, when I look at a number line, each increment or tick mark on the number line has specific meaning to it. You can almost think of it like the key of a map. If you were to look at a map and you looked at the bottom part of the map, you'd see that little key, right? That told you what the total distance on that map would be equivalent to. Although nowadays we use mostly Google Maps on our phone or iPhone, Apple Maps, or whatever it happens to be. But if you looked at a paper map or a globe or whatnot, it'd have that key in the right-hand corner or the left-hand corner. Now, looking at this particular number line, our key, the increments here, are values of 3, right? I see 0 and 3 in this increment, and 0 and -3 going the other way. So in other words, this number line is multiples of 3. This brings up an important learning point. Not every number line is increments of 1, right? Lots of times we think, okay, every number line is increments of 1, and if it was increments of 1, maybe it would be 4, 5, 6, so on and so forth. But here we're thinking multiples of 3. So if I define the rest of the increments here, this increment would be 6, then 9, 12, 15, 18, so on and so forth. Okay, so each of these are tied to a direct increment. Now on the other side, again, negative numbers are reflections. We would have -6, -9, -12, -15, so on and so forth. So this particular number line, or this particular dot, I should say, on the number line, is equal to -6. Okay, so we would say -6 is our result here. Let's look at a little trickier problem now. So again, we're asked to find where is the dot on our number line here. And in this case, we are given no 0 on the number line, and we're given a increment of 1 and an increment of 5, and they actually have an increment in between. So how do we actually solve this? Well, the first thing we need to know is what is the total distance between the two numbers that are marked, right, that are defined as. So we can see that the total distance between 1 and 5 is 4 increments. Now, we have an increment in between, so we need to figure out if this is a distance of 4, what would the increment be just between here and here? So this is an increment then of 2, right? Each increment is actually of 2. How? Well, 4 divided by 2, basically having it, gives me 2 units. So if I was to define this particular tick mark here, this would be a 3, right? 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So we have 7, 9, 11, 13, so on and so forth. Now going the other way, increments, they're different. So down 2, so down 1 would be 0, down a second one would be -1, -3, -5. So in this case, my answer for this, the reflection of +5, I have -5 over here. So my answer is going to be -5 for this particular problem. The final one I want to look at is the following here. Again, we're asked to find where is the dot on the number line. And in this case, we're given 2 increments that have one increment that's negative and another increment that's 10. So this is interesting because this isn't going from +2 to 10. If it was +2 to 10, the total distance between those two numbers is 8. But since I'm start at -2 and I go to +10, it's actually going to take me 2 units just to get back to 0. So from -2 to 0, that's 2 units, and then you have another 10 to go, which would be 12 in total. So in other words, these two numbers are 12 units away from each other. Now again, we're asked to find just this unit here. Well, we need to find what's half of 12. And what's half of 12 is 6. Okay? So to go from -2 and up 6 units, or you could even think about 10 and down 6 units, we get to the number 4, right? So if I increase 6 units from -2, it goes to, or from -2 and increase 6 units, that gets to +4, or vice versa, decrease by 6 units from 10, we get to 4. So if I keep going then, 10, and then the next unit here would be 16, and then I'd have 22, and so on and so forth. Or if I go the other way, we'd have negatives. So down 6 from -2 is -8. Down another 6 is going to be -14. And then down another -6 is going to be -20. Okay? So in this particular number line, my answer is -20. So this is a little trickier one for sure, but the principles are the same in that you're finding the total distance between your two marked numbers, and then since there is a tick mark in between those two marked numbers, you would have it. Okay, so this is finding values on a number line and defining those values. Now let's look at how to order negative numbers. So the core concept to understand when we order negative numbers, in other words, when we're defining what number is bigger than another one, is that numbers further to the right on the number line are greater or larger in value. Now this is fairly straightforward if I'm just looking at positive numbers, right? If I look at, for example, +2 and +5, and I asked, okay, out of these, which one is bigger here? We would obviously say that 5 is bigger than 2, right? We would say, in other words, 2 is less than 5 or 5 is greater than 2, however you wanted to note it. A little bit more difficult though is if I'm trying to order negative numbers and ask which one's bigger than the other one. So for example, if I had 5 and -2 here, which one is bigger here? Well, -2 is farther on the number line to the right, which means it's bigger in value. So we would actually say -2 is greater than -5 here. Now, a good way to think about this is in terms of money. So if I'm thinking about it in terms of money, think of it this way. What would you rather have in your bank account? Would you rather have -$5 or -$25? In other words, which is bigger in value? Well, if you think about it, to get back to 0, meaning you got back to where you're neither positive or negative, you would either have to earn $5, that's the negative 5, or $25. In other words, the bigger the negative number, the more debt you would actually have. So in this case, I would take the negative 5. So negative 5 is greater than negative 25. Now, I've been using these inequality symbols, so let's go ahead and define these inequality symbols again so that we have a good understanding of what they look like, because we will be using these to order the negative numbers in this chapter. So the definition of ordering with inequality symbols is this. Inequalities compare two values to show that one value is larger, smaller, or not equal to the other. So for example, this first one, I have a less than symbol. This would be, for example, 5 is less than 7 as an example, right? Greater than would be if I went the other way. So let's say I switch the order of the numbers. I could do 7 is greater than 5. Now, we also have less than or equal to with the lines underneath. When we're comparing negative numbers, we're not really going to use these exactly. You'll use these mainly with algebra. So for example, if I had x is less than or equal to, let's say like negative 2, this would mean that your answer could be anything less than 2 or equal to that negative 2, I should say. So if I was to actually graph this on the number line, we would say our answer could be negative 2, closed circle, or anything less than that. So the arrow would go to the left. Likewise, greater than, the arrow would go to the right, or you have an equal to. So let's apply each of these different inequality symbols to the following questions. So ordering with inequality symbols. So question number 1, we have negative 4 and positive 6. So this one's fairly straightforward, right? Any negative number will always, negative 4, will always be less than any positive number, in this case, positive 6. 6 is farther to the right of the number line, so it's bigger than value. So we would say negative 4 is less than 6 here. A little less known would be the negative sides. So if I have negative 4 and negative 9, which is bigger, which one's smaller? So if I graph this again, negative 4 is found here, negative 9 is found here, and then I apply the rule. The number farther to the right on the number line is bigger in value. Negative 4 is farther to the right, so we would say negative 4 is greater than 9 here. And then question number 3, we have negative 10 and negative 5. So negative 10 is found here. Negative 5 is found here. So negative 5 is bigger in value. Negative 10 is less in value. Now how this is first written is the negative 10 first. So we would say negative 10 is less than negative 5. Okay. So this is how we order with inequality symbols for negative numbers. The next concept here is to find opposites. So to define, number opposites are two numbers that are the same distance from 0 on the number line, but in opposite directions. In other words, they're reflections of each other. So for example, positive 5 and negative 5 are number opposites. Positive 2 and negative 2 are number opposites as well. Now, in algebra, we have something called opposite notation. So the same symbol, in this case, the subtraction symbol or the negative symbol, can have different meanings depending on the context it comes in. So for example, the one we're most used to is if we had something like 9 minus 3, or maybe even we had something like 5 minus 2. In this case, the subtraction symbol comes in between two numbers. So when they're between two numbers, the symbol indicates the operation of subtraction, which we would read as 9 minus 3, which is 6, or we could read as 5 minus 2, which equals 3, right? Now, if that negative symbol comes in front of a number, the symbol then indicates a negative number. So we would read negative 7 here. Or you could have negative 5 here, or negative 3 here, etc., etc. Now, each of these different numbers would fall on the negative side of the number line, right? Negative 3, -5, -7. They're on the negative side of the number line. Now, you could also have it in front of a variable, -y. So in front of a variable or number, it again indicates the opposite. Well, it doesn't, not again, it does indicate the opposite. So we would read -y as the opposite of +y. And then finally, we have two negatives next to each other. So a negative, parentheses, another negative number in this case. So here we have two signs, two negative signs. The sign in the parentheses indicates that the number is -3. The sign outside the parentheses indicates the opposite. So we would read negative parentheses -3 as the opposite of -3. And if we think about what the opposite of -3 is, the opposite of -3 would just be written as a positive. So often, if you see those two negative symbols next to each other, they're really just meaning the positive side, right? +3 in this case. So let's apply a few questions to this opposite notation. So let's say we first started with the question, simplify negative parentheses -7. So again, what is this saying? This is stating that I have a negative symbol on the outside of a -7 number. So this is stating what is the opposite of a -7? Well, the opposite of a -7, if I look at my number line here, the opposite of a -7 is the reflection on the other side, which would be a +7. So +7 would be our result for question number 1. What about question 2? So question 2 is asking us to evaluate -x when given two different types of variables here. So when it's given an x is a positive, or when an x is a negative. So -6 or +6. So what we're going to do here is we're going to write the negative symbol in the exact same manner to start, so the negative, but then we are going to input in a +6 into the x here. So +6 here. So if I solve this particular problem, what this is stating is what is the opposite, that's what this negative symbol is noting, what is the opposite of a +6? Well, the opposite of a +6 is a -6. On the other hand, if I say, okay, I have evaluate -x when x equals -6. So again, I start with the same negative symbol, but when I substitute, I am substituting in a -6 here. So what this symbol is doing then is it's saying, what is the opposite of a -6? Well, the opposite of a -6 is a +6. Okay, so that's question 2. Let's look at question 3. Question 3 is very similar to question number 2. So it's saying evaluate -n when n equals 9 and when n equals -9. So our process is initially the same. We are going to write our negative symbol, and then we're substituting in a +9 here. So now we would read this as, what is the opposite of +9? The opposite of +9 is a -9. On the other side here, start with our negative symbol, and we now are substituting in a -9. And then we can read this as the opposite of -9 is a +9. So this is opposite notation. Now let's look at a similar concept to number opposites, and this is an absolute value. So the definition of absolute value is it is how far a number is from 0. And it has a specific type of symbol for it. these two vertical lines. So this would be the absolute value of 5, for example. This would be the absolute value of 3, for example. So in each case, this is noting the distance from 0 here. Now, absolute value is always, always, always written in the form of a positive. So for example, if I say, what is the absolute value of positive 3? We would write it as 3. Likewise, if I have the absolute value of negative 3, we would also write this as a positive as positive 3. Again, the distance from 0, negative 3 to 0, is 3 total units. So if I have the following series of questions that asks me to draw each scenario on a number line and solve for each of these different absolute values, we would say, for example, what is the absolute value of negative 1? Well, if I was to plot this on the number line and move this through here, we can see that the absolute value of negative 1, well, negative 1 is a distance of 1 unit, and we write it in the form of a positive, so it would be positive 1. Likewise, if I had the absolute value of positive 1, and I say, okay, how far away is that from 0? We would also say 1 unit. Again, written in the form of a positive. Now, if I have negative 6 here, negative 6 found here, again, the distance that it is from 0 is a total of 6 units, and we write it in the form of a positive. So positive 6, or what is the absolute value of positive 6? Again, it's 6 units away, written in the form of a positive, so we'd write it as positive 6 as well, okay? Now let's apply this thought process to a series of questions where we're asked to evaluate absolute value expressions, essentially. So looking at question number 1, we have to evaluate the expression absolute value of negative y when y equals negative 15. So what I'm going to do is I'm going to substitute negative 15 into y. Now I keep the absolute value brackets the same. I also keep the initial negative symbol the same. The only change then is I'm inputting in negative 15 here that I'm substituting. Now what this is noting is we're going to solve what's inside the absolute value brackets first. It's kind of like order of operations. It says we need to solve what's inside the parentheses first or bracket first. I'm solving what's inside the absolute value first. So we now have the opposite, that's what this negative symbol indicates, the opposite of negative 15. And the opposite of negative 15 is a positive 15. So at this point, I'm now asked to find what is the absolute value of positive 15. The absolute value of positive 15 is 15, and it's again always written in the form of a positive for absolute value. So we would say positive 15 here. Let's look at question number 2 then. We're asked to evaluate negative absolute value of x when x is equal to 13. Now this is interesting because the negative symbol is on the outside of the absolute value bracket. So that changes things. So again, we're solving this expression when x is equal to 13. So my first step is to substitute positive 13 into the x variable of my expression. So I'd write the negative symbol the same directly below it. Again, the absolute value bracket's the same, but then I'm just inputting in that positive 13 into x. Now my first step after this is to take the absolute value of 13. I'm solving what's inside the brackets first. So the absolute value of positive 13 is 13. But now, since the negative symbol was not inside the absolute value brackets, it was on the outside, I did nothing to that negative symbol when I took the absolute value of positive 13. I did nothing. So that negative symbol is still there. Now what I need to do is I need to drop that directly into my answer here. So my answer would then become a negative 13. What about question 3? Very similar. We have evaluate negative absolute value of z when z equals negative 9. Question 3. So again, my step, I'm going to write down that negative symbol, write the absolute value brackets, and then I'm substituting in that -9 here. So now I need to first do what's inside the absolute value brackets. So I'm going to take the absolute value of -9. The absolute value of -9 is +9. But at this point, I did nothing to that negative symbol there. This is where this is different than a parentheses, right? If I did the parentheses, that would actually make it into a positive. But in this case, I take the absolute value of -9. That drops down. I did nothing to that negative symbol, so that drops directly into my answer choice now. And I would have -9 as my result. Okay, final concept then. Let's look at evaluating absolute value within order of operation types of problems. So a little longer problems here. So to remind you about order of operations, there's a couple different ways you could note it. Most math teachers, math instructors, mathematicians now with order of operations actually note it as what's called gamma. So that would be a grouping symbol, like parentheses or brackets, or in this case, absolute value. And then it would be exponents, and then multiplication and division, and addition, subtraction. That's where the gamma parts comes in. Or you could be PIMDAS. So either or, that's what I learned in school when I was going through math instruction. So either way, it doesn't really matter. I just put gamma here because that's usually the agreed upon rule set now here. But let's go ahead and look at question number 1 now. So question number 1 is going to be 20 minus, oops, that didn't come out so well. Let's try it again. Absolute value of 5, parentheses 9 minus 3. In parentheses and then absolute value bracket. So now what this states for order of operations, I need to do what's inside the brackets first. So 5 parentheses 9 minus 3. So I'm going to first do 9 minus 3, which is 6. That's my first step. So rewriting everything below this, we have 20 minus absolute value bracket 5. 9 minus 3 is 6 in parentheses absolute value bracket. So from here, I'm now going to multiply 5 times 6, which is 30. So we have 20 minus absolute value of 30. Next, I'm going to take the absolute value of 30, and that is a positive 30. So we now have 20 minus 30 here. And now we have 20 minus 30. And I like to think of this in terms, when I actually have this step, kind of in terms of money, because money is often where negative numbers really are applied in everyday life. So think of it this way. If I have $20 in my wallet, I then subtract $30 of value, or I spend $30. That's what this is really noting. 20 minus 30. I end up at a -10, right? I've spent more money that I have. I spent 10 more total dollars. So we write this as a -10 here. Let's look at the next question. So question number 2, I have the absolute value of -7 plus 3 times 3 squared minus 5. So my first step, I need to actually solve inside the brackets here. So -7 plus 3. If I think about it in terms of money, in this case, I have -7 in my bank, so I'm in debt, unfortunately. But then I add $3 in value. So I would end up at a -4 here. So this would be the absolute value of -4 times 3 squared minus 5. Then I'm going to finish what's inside the brackets. So the absolute value of -4 is a positive 4. So I have 4 times 3 squared minus 5. Now 3 squared is equal to 3 times 3, which is 9. So I write this as 4 times 9 minus 5. And then I'd write this as 4 times 9, which is 36 minus 5. And then 36 minus 5 is 31. Okay, and that is my result. Okay, so that ends this presentation. Again, we covered chapter 3.1, Introduction to Integers. So I would go ahead and get into the OpenStax textbook, and I would work on some of the textbook problems from chapter 3.1. If you have any questions, feel free to reach out. Happy to do additional videos if needed. Thanks, everyone.